Thank you. Can you all hear me?
Yep.
Okay, so let me share the presentation with you so that you can click on the links that I've placed there. Just give me a moment. Okay, so I'm placing the link in the chat. Actually, I received the questions like 1 hour before, so I tried to include additional points in my presentation to address those questions. So in the Q&A session, we can do a follow-up on that as well. Can someone confirm if you're able to open the presentation?
Yeah, I can see.
Okay, so let's get started. I thought I'll add, like I mentioned, I looked at your questions and I thought it makes sense for me to add more information. So, so today I'm going to give you a brief introduction of Polkadot, parachains and how they work on Polkadot, and then finally Substrate, which is what you all are interested in. I also see that next week you have a session with like Sacha from Parity. He'll be going in depth regarding the Substrate technical details. I'll keep it like at a high level in today's session. All right. Okay, so yeah, I'm a technical educator at Web3 Foundation. I've seen like someone already asked about, what this role entails. So I'm going to talk about that as well at the end of this presentation. All right, so Polkadot, it's a heterogeneous multi-chain. Okay, so that's the defining term. What we mean by heterogeneous is all these tiny dots that you see right here. So this is the Polkadot's logo, the famous Polkadot logo, where these individual dots that you see right there are parachains. And the idea is that every parachain is, is an independent team that actually puts like, a unique, customized use case as a blockchain right here. So each parachain has its own like logic. So that's the heterogeneity that we're talking about. And all of these are running in parallel, right? So we have 100 parachains. I'll talk about that number as well. Let's say we have 100 parachains right here. Each parachain is running in parallel, and that is being secured by the Polkadot network. So some of the key features, Polkadot offers is the interoperability, meaning every parachain can, connect with other parachains, interact with them, talk to them, whether they have to believe each other. So we're going to talk about that later on. But Polkadot actually provides this medium of exchange, that communication. Scalability. So we'll talk about how we can scale this architecture and how individual parachain can accommodate like more and more like applications, and then shared security. So shared security, it's a big concept in itself. I've put significant section in today's talk showing you how security works in Polkadot. So it's two-tiered. Like one is the network stake, nominated proof of staking, where a lot of people put a lot of like economic value at stake for keeping the network secure, and the mechanism through which like validators secure the network. There are two aspects to it, economic and technological. So we're going to discuss both of them. And I'd like to keep today's session like interactive. This is a small group. I know some of you already, so feel free to stop and then we can have like a chat at a specific slide if you want me to. Yeah, so all the features in a single slide, we'll get to them later on as well. Polkadot connects networks together. Like if you are a developer and then you're planning to build a parachain on Polkadot, then you can be assured that you'll have access to other parachains as well. So Polkadot handles heavy traffic. So this involves a lot of optimizations. So this is a topic up for debate and across ecosystems, like what do you consider as a transaction, right? So each ecosystem boasts a level of like, TPS, like transactions per second. So you really have to see like how many transactions are actually for the application and utility rather than like the network consensus or others. We're going to talk about security. And so this, enabling custom-made platforms, it's through Substrate. Governance. So governance is pretty unique on Polkadot. As far as I can see, if you look at all the blockchain ecosystems, Polkadot has like the most sophisticated like governance mechanism. And finally, we have self-upgrades. Okay, so there were a couple of questions related to self-upgrades as well. So I'm gonna handle them when we get to that section. Okay, so people say Polkadot is, they often compare it with like layer 1 blockchains. So layer 1 blockchains are like Bitcoin, Ethereum, etc. So that's a common misconception. So Polkadot is kind of a layer 0 blockchain, meaning, so here is the relay chain. Basically, it's a relay of, it's relaying messages of these parachains. So that's where it gets that name. So a relay chain, this is Polkadot, and then these could be like, chains like Ethereum or Bitcoin or, any other like layer 1 blockchain solutions that you hear. So they could actually be like parachains on Polkadot. So and Polkadot facilitates like communication between them and like offers them security. Yep. So, and also you have to understand that how is like Polkadot built and how are these parachains built? So right now, all of them are built with like Substrate. So Substrate is this blockchain building framework. Now, depending on your interest, like not everybody connects with every use case. So let's say you're interested in like NFTs, then my suggestion would be to, so instead of starting from scratch, you could look at several of these projects, check like their GitHub repositories, look at their code, see what problems they're solving, and whether they're solving the problems like optimally or not. So that's going to be your starting point, right? So if your interest falls into any of these areas, one way to get like a head start about development is looking at like what people are actually doing, and that is the whole concept of Web3 as well, right? So you want things to be composable. You want to build on top of like what others have already built. But yeah, as you can see, like Substrate allows you to create blockchains, like application-specific blockchains, which are capable of doing like several things. Okay, so for those of you who are familiar with Polkadot.js like UI, so the moment you open like Polkadot network, this is the interface that you see. Actually, there's plenty of information that is presented to you. A couple of interesting things are, so here you can see that there are over 9 million blocks on Polkadot already. You see the validator that has actually, packaged that block. The block time on Polkadot is like 6 seconds. And in each block, so you have a bunch of user submitted extrinsics. So these are like the transactions, like, transfer 10 dots to a different account. So that transaction, as well as some events that get like added in each block. And then the blockchain is alive and it is live as well. So you can click on this, switch to Polkadot network and see the network in the action. So someone in the questions mentioned, clearly you see that there are a lot of nodes here, but there's a big focus around like Europe in general, right? So so think about it, like you're starting a project, you need a starting point somewhere. Okay, so so Polkadot centered in like Switzerland and developers being in Berlin. it's only practical that they are the ones who are heavily invested in running this network. But again, like look at the nodes elsewhere, and how did we get there? So there are lots of like decentralization efforts from our end. If you're aware of something called as 1,000 validator program, so actually Web3 Foundation, which so I'm from Web3 Foundation. So Web3 Foundation's flagship project is Polkadot. So so Web3 Foundation has this vision of decentralization as well. So a lot of the dots that Web3 Foundation has are used to nominate validators across the globe. Okay, so there's an application procedure for it. We would want like 1,000 validators to be like these independent nodes from anywhere. They could be anywhere from the world. If they satisfy certain like metrics and then they perform well, they get nominated with the tokens, and then they can become like independent validators. So definitely there are efforts to decentralize the network. In terms of like technology, like again, you want to run nodes on like a very reliable hardware. So the easiest choice is to offload it to like cloud service providers. So it's an ongoing problem in Web3 in general. So that's a discussion for another day. But yeah, a strong independent like validators are what we are looking for in the 1,000 validators program. So not so long ago, like last year in October, like Polkadot, announced like Parachain Auctions. So the Parachain function was enabled, and from then on, like you're slowly seeing that there are projects that are winning the auctions. They are being onboarded as like parachains, and then they're slowly rolling out their functionality. As you can see, right now there are 13 parachains that have onboarded. So the para threads that you see, so the name can be a little like misleading because if you look at the Polkadot network architecture, which I'm going to show later, so para threads have what is called pay as you go model, meaning so parachains win the slot auctions, they can live on the Polkadot for 2 years. Whereas para threads, like when the functionality is implemented in full, they can actually include the blocks whenever they want. Okay, so for every block, they have to do an auction and then include it in the relay chain. So that is not implemented yet. So here, a para thread is basically any blockchain project that plugs into like Polkadot and then makes an auction to become a parachain. That's something you have to keep on mind when you see a para thread here. But yeah, so there are like 13 parachains that have onboarded, and if you're following like individual parachains, like you would keep hearing that every week or 2 weeks they keep like rolling out like new features, right? So they're upgrading their blockchain as the time goes, and Substrate is what allows them to do those upgrades without actually forking. Okay, so one more thing I want to highlight for you as developers. If you're designing a blockchain product, then you would want to ensure that not only the logic is correct, the code is bug-free, and also because a lot of blockchains are used by, they're decentralized and then they're used by anybody. So you'd want to see like how your code, your logic performs in the real world with like some real economic value at stake. So Kusama is that blockchain network that gives you that kind of option, right? So before you move it to like Polkadot, which is like enterprise level, like blockchain, you would want to test like your blockchain product on Kusama. So a lot of teams have like a blockchain, a parachain on both the relay chains. So Kusama and Polkadot, and even for Polkadot, like if you want to upgrade some features on Polkadot, those features will be tested on Kusama first. Only when we're confident that the features are working properly, we move those features to Polkadot. And because like it's a canary network and it has started like much earlier than Polkadot. So there are over 12 million blocks already. And as you can see, rest of the parameters, they look very similar to Polkadot, right? So the block time is like 6 seconds. You pretty much see similar events on Kusama as well. But clearly it hosts like more parachains than Polkadot because the auctions have started like well in advance last year. So the idea is to keep adding like parachains aggressively on Kusama and try to see like, what issues come up, right? So regarding the question on why 100, like why do we say there will only be 100 parachains on Polkadot? We don't know that number yet. So we're just throwing a number saying like, okay, so given like, the code, the testing, the benchmarking that we did, we feel like 100 parachains can run, without any issues, and have this interoperability and shared security all delivered properly. So that 100 is not a number that is set in stone. We are actually discovering it by, adding more and more parachains. So how else would we test it, right? Like we have the test networks, we can create nodes, we can spin up the nodes in the cloud and make them interact and say, okay, so this works. But the real world blockchain networks, they're unpredictable in a way. They're geographically like spread out. The only way to know that something works is to actually, see if it works or not by adding more and more chains. So Kusama has that vision. Like Kusama is the one that's going to keep adding like parachains every week, whereas on Polkadot we have auctions like every other week. So the plan is to keep the number of Polkadot parachains like lesser than number of parachains on Kusama. So that way, about like 75%. So that way, if something were to break, it's going to break here rather than on Polkadot. And like the slogan of Kusama is, I don't know if it shows up here, it's called expect chaos. So meaning the network is actually prepared for such chaotic, moves. So yeah, so also one key difference that I want to mention between Polkadot and Kusama is in terms of decentralization as well. So Polkadot has like 297 active validators now, and Kusama has like about 1,000. And a lot of the 1,000 validators program that I mentioned. So in these 1,000 validators that we have, a fraction of them are through that program, and so we're adding more and more like validators here. So the way this works is around 1,000 validators are involved in producing the blocks. There could be more validators who are waiting, okay, so to get added to the network in the next era. So roughly, I think it's about 2,000 nodes that are actually willing to be validators on Kusama, which is huge.
Sorry, Radha, I have a question about this picture.
Yep.
What is the difference between the gray color and the Polkadot color? You see the surface the color is gray.
Yeah, so let's see. I think so. This one is like a third-party like app, which I felt was cool. So let's see like what they mean with that color schemes.
Yeah, actually, Sacha showed this website to me last day, and I was still curious about it.
So actually, let's see if this connects in a bit. But pretty much it's just like a visualization, I guess. I think some of them might be like para validators, and some of them could be, regular like validators. It could be, but as you can see, like some, yeah, so let's see. Yep, so it looks like these are like para validators, right? You see them, the name para validator right there. So each of these validators are assigned to a certain like parachains. So I'm going to talk about this during the network security. But yeah, so yeah, these are so it's just for like visualization. So they made like really cool visualization of how the validation is sort of working. All right, let's go here. Not this one, wrong one. All right, so where were we? Okay, so talking about connecting the networks together, right? So now anybody who enters like Polkadot ecosystem, they would in general like know about like Bitcoin, blockchain, or Ethereum, or maybe Cosmos, Avalanche, or others. So so Bitcoin and Ethereum, right? So a significant distinction between these two is Bitcoin is good at what it does. What does it do? It's like a distributed ledger. It keeps track of like transactions from one account to the other, and that's all it is capable of doing. People have tried to add like more functionality, do more with Bitcoin network, but it simply doesn't let you. It only lets you to a certain extent, to be able to customize like what you can do there. Whereas Ethereum is also a layer 1 blockchain, but it allows you to do a lot more things. So it's what we call like a Turing complete like blockchain. So anything that can be executed on a computer can be executed on Ethereum blockchain, only that you have to end up pay the execution fee in like Ether. So the idea of Polkadot is that these individual parachains are those layer 1 blockchains, as I mentioned earlier. So each blockchain can have its own token, so they don't need to like use the dot like Ethereum. So here, to do any operation on Ethereum blockchain, you need Ether, whereas a blockchain becoming a parachain on Polkadot, so it can have its own like tokens, its own governance, and its own like logic. Dot as a utility token is only used to acquire like the parachain slot. So okay, so that's one distinction that you have to understand. Now, so what's the benefit of becoming like a parachain on Polkadot, right? So that we're gonna explain that when shortly in the next slide. So the first thing is there are already ecosystems out there, and then there are bridges in development. So any sort of economy or functionality that you have in Ethereum or Bitcoin or Kusama, you can actually bridge it to like Polkadot. So these are under construction. But the main thing about like becoming a parachain is being able to like talk to other parachains, and not get like, what do you call? So if you heard of like the hacks and scams that are happening for the past like few months, so every week you keep hearing there's a hack of that bridge, there is a hack on this bridge. So the XEM, with XEMP, so it doesn't allow you to like hack at the protocol level. Shortly, like how would I put it? The entire communication here is protected by the whole network security. It's not like a limited set of validators. It's actually the entire network security that is backing the cross-chain communication. The next question I usually get is, okay, let's say this parachain talks to this parachain. Fine. So Polkadot ensures that that message goes without like any tampering, like it goes as intended. But can this parachain trust this parachain's like core logic? So that is not the job of Polkadot. So that's the job of the the Parachain project. A simple example is if a Parachain has written a logic that can be like hacked, so there's nothing Polkadot can do about it. So I'm going to explain why that's the case in a bit. But you have to understand that assuming that this parachain executes the code, properly, and this one executes the code properly without any bugs. Polkadot will ensure that everything is conveyed without any sort of issues. So with respect to the difference between XCM and XCMP, so you have to understand that XCM is just a format. It's the common language that different entities can understand. So it's more like HTML. So if you're familiar with like HTML, there are so many browsers. So each browser knows like what to render when it looks at a HTML code. Whereas XCMP is more like the transfer protocol. It's like HTTP or TCP, UDP. So there are multiple mechanisms through which like you sort of send the data across different entities, right? So XCMP is that. So as you can see, so the C here is also different. So cross consensus message format. So what this means is there are different blockchains. The blockchains could have like their own logic, and that logic can be upgraded. Still, like they should be able to talk to each other. That is taken care by XCM. It's at the semantic level. Whereas cross-chain messaging protocol, it's slightly different. It's about, okay, so I'm on Polkadot. Okay, so do I send the message through Polkadot, or do I directly send the message, to the parachain, establishing a connection? Can I just send a cross-chain message directly without involving like Polkadot, right? So that sort of like communication is taken care by these standards. Like, so XCMP is that like cross-chain messaging protocol. So VMP, it's like vertical message passing. So you could also send messages to the relay chain and also download messages from the relay chain. So the best place to get your answers is the GitHub repo. So let me click on that. Okay, so you can't beat this source of knowledge, like, because this is where almost like every everybody goes here to get a sense of like what this format means as a developer, and then get started from there. But if you're not like a core developer yet, I would suggest like Stack Exchange. Like it has become like popular these days. So it's giving a lot of answers. So these 3 questions that I put in the links. So if you're opening the presentation in the Zoom link, click on them, and then it takes you to the core Substrate developers who are actually building like XCM. So they have the answers for you right there. So I would say, make use of these resources as well. Okay, so Stack Exchange is where like all the developers are hanging out for the past like 1 month. So just ensure like you have your presence there. All right, so let's do, where are we? Okay. Yeah, so things to remember. Let's do. So XCM is about like cross consensus message format. So it's like establishing, okay, what does a balance transfer entail, right? So let's say I want to send parachain token A from parachain A to parachain B. So what are the instructions that I give? Like, a common messaging format that I'm going to stick to, and the implementation is going to be like, not dependent on that. So it's like native to the blockchain. So yeah, so take a look at this, and there are articles on XCM written by Gavin Wood. So those are also a good introduction to what XCM is. And XCMP is more of like a protocol. Okay, so this is at the networking layer, and this is like the logical semantic layer. All right, so we talked about like custom built blockchains. So I'm going to show briefly how Substrate achieves this. So let's say you're a DJ in a music party. Depending on the song, you would want to adjust like different parameters. So this is exactly what, Substrate developers building parachains also do. So they're going to get like, Substrate code with a bunch of like palettes. So they look at like which palette they need, what kind of performance they would need to sort of execute their core logic, and then they have chance to sort of like customize that. All right. Yeah, and also Substrate provides this, Lego block style development ease, whereas you have a bunch of palettes. So let's say I want balances in my blockchain. So instead of like doing everything from scratch, so I'm going to import that palette, and right now I have my accounts. I have the ability to transfer balances and so on and so forth. And also like governance, like if you don't want to do everything from scratch, you can import that right away. Yeah, and someone asked in the questions that how decentralized, Polkadot is, and what stops people from like taking over the network, right? So, and if I have smaller stake in the network, is my voice still heard? So these are like very important questions for like the developers and the researchers here at Web3 Foundation and Parity. That's why we have something called as fragment election, like the nominated proof of staking actually takes the minority's voice into account while picking like the validator. That's one of the, so that's one of the key objectives that the NPOS algorithm works on. And even in governance, like we have this unique feature where what we call conviction voting. Like if something matters to you a lot, you can actually lock up your dot for significantly longer time, and then get like 10 times the voting power than the regular person who locks in just for like 0.1 voting power. So there is like infrastructure in place to make sure the minority's voice is heard. So we have like governance channels as well. So one of the recent proposals to sort of extend crowd loan, on Polkadot. So that was not well received by the community. So people have actually gone to the governance channels, and then so they educated people about so this is something against like the core principles of like trustlessness, and people have actually heard and then flip their vote. It's not like you vote yes, that's going to be yes. So you have the opportunity to change your vote before the referendum gets passed. But yeah, so you have to understand that there are blockchains out there without any governance, and some have governance, but they are in a very limited hands. Polkadot is here. Okay, so seeing like what's happening on Polkadot, and what kind of proposals are passing, you can see that it's somewhere in between. It's a spectrum. So we're slowly transitioning from this to this. But yeah, so check out like the governance. So the governance tab on like polka.js. So you'll see a bunch of things like treasury, referenda, tips, bounties, etc. So there's a lot that is going on, and also the governance module itself is being upgraded. Like within 1 or 2 months, you're going to see that the council is going to disappear. So because people think that a bunch of councilors is some centralization of power, so we don't want that. There's also talks about like technical committee and the power of technical committee. So even that is going to be taken care of. Ultimately, we would want like different. Right now, there is only one referenda that can be active. So we would want referenda in like different, so different tracks. Technical referendum, public referenda, etc. So there's a big like reorganization going on in terms of like governance. So I'll keep you posted. You also like stay updated with the updates in governance. Yeah, so you can view like all the governance in action on Polkadot or Kusama. So just go there and then you can see a bunch of things like happening there. So the interesting thing about governance is that it's not like you put a proposal and then after the proposal gets approved, you upload the code. It's not like that. So you already add the code along with the proposal, meaning when you're actually voting on a proposal, you actually know like what this is going to do. Okay, so that code itself, so if it compiles to WASM, so there's a way to like verify whether that code is like, well, doing what it is supposed to do. So once the governance, proposal becomes a referenda and gets enacted, the core logic always like can be put on the network and immediately like the change is reflected. So this answers the other question someone had about like forking, right? So let's say I put a code out there, upgrading the parameters of the network or functions of the network. So it gets voted upon. So instead of like validators or miners deciding which one is the canonical chain, so everybody interested in the future of the network is going to vote for it. Okay, so only when the proposal passes, becomes a referenda, and that's voted yes by all the interested parties, which can include like validators, nominators, institutions, whoever is interested in the future of the blockchain network. So they are going to ensure that this proposal should be a go or no, and only then the code actually goes onto the network. And once it goes onto the network, like everybody has to agree on it, right? So why I'm going to mention that when I get to the self-upgrades part. But yeah, so that's how governance works in Polkadot. It sort of eliminates the need for forking in the network. All right, so here is where I'll spend 10 minutes, and then I'll finish up the presentation after that. So let's talk about security, right? So one of the promises Polkadot makes is that every parachain security is equivalent to the entire relay chain security. Meaning, if you want to attack like one parachain, then you have to attack the entire network for it. So let's see like why, and how, like technologically or technically how that works. So first of all, the security from the security on Polkadot is derived from nominated proof of stake. So if you looked at the snapshot that I showed earlier, so there are over 1 billion dots in circulation. So one of the fundamental like utility of a dot token is that you can stake it, right? So what you do is if you have some dots, you're going to stake or nominate it on a certain set of like validators, and you entrust them to run the network properly, without executing any malicious code, without being like reckless or careless. So you want them to stay actively participating in like validating the network transactions, and you do that by putting some stake on them, and they get elected. So they deliver their tasks like as expected, and you're rewarded with a certain percentage of your stake as rewards. So that's the ideal scenario. But not everything in the world is good. Like, there are bad actors out there. There are people who would want to attack your network or take down your network. So let's see how costly such attack actually is. So if you look at the architecture, okay, so we have the relay chain that is protected by the nominated proof of stake of dots. And then we have individual actors who are like parachains, right? So one term that you have to be aware of is the relay chain has validators. So these are the validators, the vertical sticks. These, tiny dots that you see. So those are like collators. Okay, so collators are, the nodes that actually run on parachains. So you have to understand that parachains are blockchains as well. Okay, so we have a blockchain, which is Polkadot, that is adding blocks on top of each other. And every individual parachain is also a blockchain. It's also adding blocks on top of each other. But what it's doing is it's going to pick a certain collator to send the block to the relay chain. Okay, so once it goes to the relay chain, the validator picks up the block, validates it, and then finalizes it on the relay chain. So now, interesting thing here is the relay chain doesn't store the entire block of the parachain. It beats the purpose. It's going to blow the relay chain out of proportion. So it only stores what's called like it's like a certificate, right? Okay, so this particular block from this relay chain, looks good. And once that confirmation happens on relay chain, the parachain can be confident that, okay, so this particular block is finalized. I can, keep adding more blocks on top of it. So that's how the architecture works. And as you can see, it is the validators who are of the relay chain that are very central to this happening. Now, you might argue that, okay, so each parachain is having like 5 validators assigned, to do para validation. What if I have like 5 validators and will I be able to corrupt a certain like parachain? So to do that, so you'll have to understand that, the validator group that is assigned to a parachain, that is random. Okay, so Babe is the randomness beacon on Polkadot. So it's going to randomly assign those 5 group of validators. We can actually see this in action. So let me go to Chrome browser, and then let's see what we have right now. Okay, so this is like Kusama. I'm gonna just minimize it a little bit. Okay, so if I go to this, so you see these. So statement has these 5 para validators, or so it actually switched for the next block. So if you just like observe that, so this sort of switching of these validators, so there are 1,000 of them, and then Babe is going to like Babe is like the one of the Babe and Grandpa. These two are together like the consensus engines on Polkadot. So that sort of takes care of this flipping. So you can't orchestrate an attack like well in advance. So it's so difficult with it is so difficult with this sort of clever engineering where the validators are initially elected based on like nominated proof of staking. After you get elected, then you're like randomly assigned to do like para validation. So for you as an evil actor to actually have a significant damage, if you want to make a lot of damage to the network, you first of all have to have a lot of stake in the network, and then you don't know whether your validators are going to be assigned to a parachain. So only when you are assigned, so that's when you have some influence over the network. And also I should remind you, the slashing offenses of like running malicious code or doing deliberate damage is almost like 100%, meaning once you do such thing and you get caught, you lose your entire stake that is backing those validators, and you can't keep doing it. Okay, so and then the governance will let you like revert something evil of that sort. So there are several checks in place which ensure that such an attack is not possible. So you have to understand that anything is possible. Like in the blockchain world, people can be evil. They can spend a lot of money and effort to orchestrate an attack, but why would they do that? So think about that logically. So someone with such a large stake would want to improve the network more and then benefit out of that stake. So all in all, like the sophisticated network architecture of Polkadot will ensure that the parachains are actually secured by these decentralized set of validators who are sort of assigned to it. And yeah, so I should also like highlight this article. So if you're interested in what all happens when a parachain actually, Collator creates a block, sends it to the relay chain, how does the relay chain validator validate it? right? So what data would they get, and what would they do with it? So read this article. I'm going to try to summarize it like very briefly. For those of you who are aware of like, blockchain data structures, so Merkle tree is, like this really popular blockchain data structure. So the way it works is, so you have blockchain state, right? So let's take a substrate based blockchain. So you have balances. So let's say you have a Polkadot account. So you have an account with a certain balance. So Polkadot network also has like democracy module. It has a bunch of things. So let's say I'm sending some balance from one account to the other, and the democracy referendum like moves ahead to the next one. So the changes are occurring at, specific locations in this Merkle tree. So someone sent some tokens. So Luis sent Ben like 50 tokens, and then democracy moved to like the next counter. So the other things here, so they're not changing. Like, validator count is still 500. Babe is like whatever 7 or so all of those are not changing. There are only few things in the parachain core state of logic that are changing. So that change is what needs to be delivered to the relay chain. Okay, so the relay chain doesn't care about the parachain's entire state. So it only cares about how things are changing on parachain, right? So it's almost like in math, like, you have like a big curve. We don't care about the value of that curve. We are only looking at the rate of change of that curve, right? So it's like the derivative that of between the parachain state between blocks that the relay chain is interested in. So you'll send only this data. Okay. So basically, the block consists of the list of like state transitions. And yeah, so this is what we call proof of validity. And why is it proof of validity? So the parachain starts with an initial state, and it always records the transitions with the relay chain. So to achieve the current state, it can always start at the initial state and follow the exact steps and reach the same state, right? So everything is deterministic here. So to add like one more block, you can just submit this proof of validity, and then it's going to take care of that sort of transition. So I hope this all like made sense so far, like how Polkadot is actually securing a parachain, right? So parachain submits this block. It makes sure that this block is sort of validated by this randomly selected like active validators, and it does it this way. It includes the certificate of validation in the relay chain, and the parachain can okay, so that block is final. It has been protected by Polkadot. So now I can add the next block onto the blockchain network. Yeah, so this is the most favorite feature of all the developers that I talk to. It's the self upgrades, right? So not every chain that is non-substrate based like blockchain has this capability. You can start with a blockchain product that looks like this, and then over the time you can actually upgrade your blockchain like this one. So Substrate actually gives you that sort of freedom. And yeah, so a conventional blockchain upgrade looks like this. A bunch of miners or validators decide that this is the canonical chain, and there are few who disagree, and then they end up like adding different blocks on top of this one. So this is not even like possible on Polkadot. We already mentioned that such conflict is resolved through governance. Like if people decide on something and that governance proposal like becomes referenda and it gets passed, so the code, the runtime upgrade itself, it's part of the block, right here. So while adding a new block, what happens is the validators actually download, the state from the block, and the WASM code, the state transition logic, and they execute it to build the next block. So that way, keeping like the blockchain's core state transition logic inside a block sort of makes this sort of runtime upgrades possible. So this is like almost very futuristic, right? So it's almost like you have a smartphone, you have an app, and then you can push updates onto your app as time goes, right? So all the parachains which are built with Substrate can also do this runtime upgrades. Perfect. So I have rest of the time. So this part, like I mentioned, Sacha is going to, from Parity, he's going to go in depth. I'll give you a high-level overview of what Substrate is and why you should be interested in building on Substrate. So it's a modular, flexible, and extensible framework. 3 different terms, but they're very related. So modular, meaning, okay, so I want to focus on a DAO, like, a governance-based blockchain. So there's a governance module. Okay, I want a blockchain just to do some balance transfers. So there's a balances, like, module palette. And on top of it, those individual modules are flexible, meaning you can plug and play with them. So they're so flexible that you can actually remove one and actually put another module instead of them. They're extensible, meaning, so let's say you're not happy with the functionality provided by a palette, so you can extend the functionalities inside that palette. So you can add your own custom logic. You can change, like, few fundamental things about that palette and still make it sort of work. So one good thing is, all these Substrate-based chains are running, so everything works out of the box. Okay, so you download the Substrate template node, compile it, run it, so you can be ensured that it sort of runs a blockchain. Yeah, so one thing about, like, so being a Substrate developer, so there are 2 different things. One is developing Substrate itself, which is Parity's job right now. So they're spending a significant time developing Substrate, the core primitives of Substrate. And the other thing is developing on Substrate. Okay, so you have a framework, you as a developer want to do something with it. So as a developer on Substrate, you would first be looking at Frame. Okay, so Frame is this bunch of libraries, which we call palettes. So they are available for you as a developer when you're trying to develop a blockchain application. So the way it works is, as a fresh developer on Substrate, the first thing you get exposed to is a Substrate node. It's like a Substrate template node. It has like minimal logic, and with a template palette, you're free to like develop whatever you want there. Excuse me. And then you go a little further, work with like Substrate frame itself, like the palettes, develop your own palettes. And then if you've become like really good with like everything, so you can actually mess with Substrate core primitives. Okay, so starting with the cryptography and all the other primitives in there. So as you can see, it's easier to start here and then slowly go here if you want like more freedom. Yeah, typically it works this way. So you can pick and choose like what palette you want, and you can put that in the blockchain's like runtime. Earlier, like I wanted to do, a workshop style session, but I knew that you're going to have this session like next time. So I'm just going to skip all of this, and then let's see what important things I have to mention. Yeah, so Substrate template node, feel free to like download that. Yeah, and if you want to quickly like check without even like installing, like if you want to quickly check like what Substrate is all about, so feel free to open playground.substrate.dev, and it should let you, so let me open this here. Okay, so it already has like the starter code for you to like play around with. Like you don't have to configure anything on your system. It works on a browser. So let me create this and see like what goes on. So basically you have a Substrate node template that I've shown earlier. So you can actually compile that on your local machine. Or if you want to get a look and feel of what it exactly is and its code. So you could actually go to the playground and see it in action. Okay, so right now it sort of initiated the blockchain. So it looks like it imported the first block, and you'll see this happening like every 6 seconds. It's adding like a new block. So basically, it's a working blockchain. But if you look at the actual like logic, so if you want to interact with this blockchain, let's see what happens. So Polkadot.js is the front end. So I went to Playground, and then I clicked on open Polkadot.js apps. So basically, whatever is happening here on the command line, it's presented in a beautiful way on Polkadot.js UI right here. So in this particular like blockchain, the bare minimum like skeleton blockchain, you could actually see that there are a bunch of like accounts already created. They already are there from the genesis, like the first block of the blockchain. If you're interested, you could actually take a look at them in the code. So let's see. So the chain spec, okay, the chain specification, that's the file that has like all the accounts that you see, Alice, Bob, etc., whatever. It's very interesting, like how the code is sort of organized. So you see these palettes. So if you were to develop like your own palette, you're going to include it here. It's going to have like a lib.rs file. So it's a Rust file. Yeah. So and what else? Like runtime. So okay, so runtime is the core logic of the blockchain, right? So all the palettes that you define here, so you have to compile them together in the runtime and make sure they work well together. So more on this, I'm going to, so let's see, I just have like 1 minute. So I'm just going to finish the presentation. Yeah, so if you want to get started and have, a lot of questions to Sacha, then I want you to click on this particular link. It's by far like the best tutorial I've seen that explains how to create your own palette. Okay, so I would want you to go over like the basics that are given, try out like all the exercises there. So there is a task as well as the solution. So if I go further and further, so after introducing a lot of concepts, so you have the actual exercise. So here you have action item and you have a solution here. So make sure you don't look at the solution, give it a good try to do it on your own, and then try to make progress. So you have about a week before the next session, right? So ensure that you're well prepared to ask specific questions and make the most out of that particular session. Oops. Yeah, I think so. That and where's my presentation? So I think I'm done with this. We can have like more interactive, questions now. Let me see if. Yeah, so these concepts, like you'll get a good idea in that tutorial. And something about the naming in Substrate. So if you see SP, it's Substrate primitive. So if you see SC, it is Substrate client, something to do with like the nodes. Obviously, like frame, it's very clear. So palette is something that is customizable, and you can create your own palettes. So which exactly means this? For you as a developer, you're going to start here. You're going to, with Substrate Kitties, you're going to learn how frame works. And then once you're comfortable, you can also like look at the core primitives of like Substrate. I'll skip this session, this part. So one thing I want to mention is, so there are people who say, why do we need like auctions? Why can't I be a developer, create an application and deploy a parachain on Polkadot? So that's a really, really good question. Like in the world of like decentralized, technologies, like why are we doing this gatekeeping of who can become a parachain? So if you think of it, somebody needs to do some level of quality control somewhere, right? So parachains in themselves are like layer 1 blockchains, which are capable of hosting applications on top of them. So now if you're saying Ethereum has like, it's open, anybody can develop an application on it. So you could actually do that on a parachain, on top of a parachain. You don't have to become a parachain to do it. So the idea of this is, if you open up your app store for anybody, people can create like apps that are scammy, that don't work. There's no quality control on it. But think about like an app store that can keep some quality, right? So how do we keep the quality? Keeping the public engaged, like, with crowd loans, with like, auctions, there is a community that is going to support a certain kind of blockchain to be part of the ecosystem. And it's like a self-driving like engine where quality projects will always make it to the ecosystem, and the ones that are scammy or bad, they are kicked out of the ecosystem, right? So if that makes sense. There are more follow-up questions on this. I hope you can ask that. One clear thing is, one question I often get is, what happens if a parachain loses an auction and gets disconnected from the relay chain? So I'll explain that, but I'm opening up like the floor for user questions, and then we can talk about it.
Okay. It was an intensive session to learn about Polkadot and Kusama structures. I think Polkadot is like saying, I prepared everything because I don't know what you want. And thank you for your presentations.
Mm-hmm.
Following
I want to thank all of you too for like patiently listening.
Okay.
Looking forward to the questions now.
Okay, following this session, we will have a question time. And hello, I'm Terry, non-admin in this project. I'm reading Blockchain Society and Ewha Women's University. I feel quite honored to manage question sessions. You can ask a question to Radha through chat or voice, and I would appreciate if you could briefly introduce yourself before asking questions. May I ask you a question first? Okay. I think the Substrate frame is convenient unlike other chains. So should I think it provides the same role as Ethereum OpenZeppelin? I think similarly because OpenZeppelin helped me form a contract.
Yeah, so one thing you have to understand is, so Substrate is more than like smart contracts, right? So smart contracts are only a part. Like Substrate gives you the flexibility to even, go to the core logic of the blockchain itself, like the blockchain primitives. So for instance, so the way Substrate works with generics, like next week, like make sure that you focus on this. So generics on Substrate will ensure that multiple things can work together. Like you can have Ethereum format working with like Substrate format, etc. So all of this is possible because of like Substrate's framework in general. So Substrate is definitely like a superset of the tool that you've mentioned on Ethereum.
I fully understand. And my second question is, I'm an undergraduate student majoring in computer science and interested in blockchain education. And I'm curious about how you came to do the tech education lead. And also I'm curious about what competencies or performance I need for this kind of position in foundations.
Yeah, so I mentioned earlier, I saw this question already. It's interesting, right? So I did my PhD in computer science. So I was doing some artificial intelligence. I have like a course on computer vision on Coursera. So feel free to look at that. So I was doing all of that. And then I was like really interested in what's happening in the blockchain ecosystem. So I think the first time I was very intrigued was looking at the core functionalities of Ethereum, right? So I mentioned earlier, Ethereum is Turing complete. So I used to teach theory of computation, and I knew what Turing complete actually means. And knowing that there is like actually a blockchain where you could run like any sort of application was very fascinating to me. And that particular, you can think of Ethereum as like this global computer where if you have like Ether, you're sort of like able to execute like anything that you want, as long as you have the Ether as the gas. So all of this interested me. And then with my background in computer science and like distributed systems, I've seen that Ethereum has some scaling issues. Like, after a certain point, it doesn't become like feasible for, anybody to sort of like work on Ethereum. So then I started to look for solutions, who is actually, trying to solve such problems. So that's when I stumbled on like Polkadot, the technical education channel on YouTube, Bill Labun, who's like the technical educator at Polkadot. So it was like very organic. Like I looked at that, I was really connected with the vision, with the vision of like Web3 in general. So I applied, and then even though I had like less like blockchain knowledge, so I was considered for the job, given like my skills of like teaching in general and like my technical background. So I came here, and then things change like every day. Every week you hear like a new feature rolling out in like Substrate and in the ecosystem. So yeah, so that's how if you're interested, you keep like learning, like it's an everyday thing. And then once you're doing well, you teach it to others too. And that was my path towards like becoming a technical educator. And again, like if you're interested in that role, we definitely have like openings. Like if you go to jobs at Web3 Foundation, so you'll see several roles there. So there's a technical educator role as well. So if you think you're a fit, feel free to like apply, and then we'll sort of welcome you.
Oh, I still study hard about these skills.
That's the thing. Like, I think it's always about connecting to the vision. So if something really makes sense to you, then you will sort of learn what is required to make that vision like a reality, right? So it all like works that way. And you'll definitely have people around you. It's not a single person job. So it's always like you have people collectively like working towards a vision, and that's what makes it more exciting.
Oh, it's a word that has a lot of influence on my career path. Thank you for much for your answers. And next, now I'd like to invite any question you may have and chat. Are there any questions?
I have one question. My name is Dongchang Lee. Maybe my name is in Korean, so you couldn't read it. You can just call me Lee. I'm currently working on blockchain startup. One question for the para validator and the collators. So what I understand was that collator doesn't change, right? They're just the validator for the parachain. And I couldn't fully understand the difference between the para validator and the collators. Can you just give me the hint of it?
Yeah, a very good question. So so think of, like I mentioned, Parachain. Like if you're a developer, trying to build a blockchain, you need a full node, right? Like that's actually like talking to other nodes in the network. So you can think of those nodes of your blockchain as collators. So becoming a parachain on Polkadot means the validation of the transactions is not performed by the nodes on your blockchain. Instead, that is offloaded to the validators on Polkadot. So collators, so their job is to just collect like the transactions that are appearing in your blockchain network, packaging them into this proof of validity block that I showed earlier, checking like the current network state, seeing like what is being changed. So it converts the transactions into that proof of validity block and sends it to the relay chain validators. So relay chain has about 300 validators or 1,000 validators. So on the relay chain, those para validators are randomly chosen. So that group of 5 people are going to get your block sent from a single collator on your project. So these 5 people are going to ensure that everything is working well. The state transition is proper. There is no, so there's no invalid transaction in there. So if they give you that certificate, then you're confident that that particular block is final on your blockchain.
Oh yeah, I got it.
Yep. So basically collator thing, even if you have one collator on your project, like blockchain network, it suffices. If they're available to send like, block after block, it's fine. People tend to have like more than one collators because, so they just want to decentralize that part as well. And collators can actually, they don't have the permission to mess with the state, like they can't do evil things, but they can always like censor transactions, right? So if you don't like somebody, you're like, okay, I'm not going to send this transaction to the relay chain, so they can actually censor your transactions. So that's why even if there is one honest collator on the network, the transaction will eventually make it to the relay chain.
Yeah, that makes sense. Yeah.
Mm-hmm.
Are there any questions? Oh, if there's no questioner, I pick the person to ask.
Sure.
Oh, I have questions. Okay. Hello, my name is Haemin Kim. I have 2 questions for your lecture. So the first question is, I understand that Polkadot can update itself unlike existing blockchains, so it doesn't cost forking, right? So was it a technical problem that the existing blockchain couldn't do this? Like no forking. Do you understand?
Yeah, I think I do. So first thing, so how does Polkadot like upgrade itself like without forking, right? So I mentioned in Polkadot like blockchain, like the blocks. So they have the state. The state is basically, so let's say you own some dots. So your account details, your account ID with that associated balance, everything is part of the blockchain state. So along with that, you have the state transition logic as well, which is like a WASM blob. So WASM means like WebAssembly. So it's like if you're if you're already familiar with WebAssembly, you would know that it's platform agnostic. So it can actually run on a browser, on like any sort of platform. So you have the code which will be used to process a transaction. So let's say you send some balance to somebody else, the way it gets executed, it's executed through that state transition logic. Now with a runtime upgrade, you're changing the state transition logic, with which like you may execute the transactions. So this code change is done through like governance. So it's not like in conventional like blockchain networks like Ethereum. So if somebody changes the way Ethereum, should, if it changes the state transition logic, then the node that downloads that logic is the one that is going to execute it. So there could be other nodes that would say, okay, so we don't want to download this upgrade. Sorry, we don't. We want to do our own thing, like what we have been doing so far, and they keep processing the blocks based on the older logic. Make sense? And the upgraded nodes will start executing blocks with the new logic. So Polkadot solves this problem by, not giving the validators an option. So if a validator has to, validate a block, the state transition logic is part of the block, and you have to use it to sort of, process the transaction. So in order for the new upgraded feature to get on to that block, you have governance. So that is where the validators, nominators, institutions, whoever holds DOT are going to say yes or no. So once that passes, then it's like a seamless upgrade on like blockchain. Hope it made sense.
Thank you.
So that's the clever meta protocol design that Substrate sort of has. And it's only like, so always like people take some time to appreciate like, futuristic stuff, right? So this is slowly like making sense to people who would want to like keep things like future proof, because anything can happen like anytime. So you want to be able to be prepared to upgrade your network when you actually need to.
Oh, thank you. I have second question. I think it's a little bit similar with first question, but I'll try. I'm curious about the part that related to governance, that the existing blockchain, one person or a small group decide the future of the network. It was presented in the presentation. So, but I understood that if anyone who have a DOT token, they can participate in network operation. Is it right?
Yeah.
But I don't know the difference between the existing POS method and Polkadot, because I know POS method is similar. If they have a stake, they can
vote too. So let's say you have staked your dots in you nominated like a validator. So they are still your dots, right? So you can actually participate in governance with those dots too. So it's not like you just like, so this is a little different. Like with crowd loans, like you're giving away dot, like you're loaning your dot to someone to sort of get the auction, win the auction and get the lease. So they are not yours, like you loan them. So that's why when you use crowd loan functionality, you won't be able to vote with those tokens, but staking or other things like reserving your dot to get an identity. So all of these are your own dots. So you can always use them to sort of vote on like referenda. So I could, can I share my screen again? Let me share that.
Okay, 1 second.
Yeah. Can you see my screen?
Yep.
So let's go to the, here. So let's see like what you would see on like Polkadot governance. So democracy. Yeah, right now we don't have anything. So if you had like a bunch of accounts here and you have like dot balance, you can participate in like network staking, and with the same dots, you should be able to participate in governance as well. And when you're voting on a governance proposal, you have like a multiplier. So you can say with multiplier 0.1. So what happens is once the referenda time is finished, because everything is like timed, right? Like 2 weeks, the decision has to be made. So once the decision is made, like yes or no, you get your tokens back. But if you use conviction voting, let's say I put a multiplier of 10, then you're locking your tokens for, let's say a year or so. But for doing that, you're getting 0.1 to 10 is like 100 times. So you're getting 100 times more voting power than the person who doesn't really care about that particular referendum. So this is for amplifying like the minority voices. So there could be a majority which doesn't care about whether something happens or not, and there's a minority that strongly feels the network is going to benefit with this particular feature. So they have a voice with this, what we call conviction voting.
I understood. Thank you.
Yeah, and no other like blockchain network has stuff like that. And even like the nominated proof of staking. So the election algorithm, others tend to simply see who is the maximum staked validator and then let them sort of enter, active set. In Polkadot, we have fragment-based like election. So it sort of spreads out the nominations across validators. So it makes sure like multiple objective functions are optimized, and that's why it's so complex. Yeah, people are optimizing it and improving it further.
Okay.
Okay, very interesting questions.
Juan, or you have a question?
Yes. Hi, I'm a developer of a game company, and I'm junior developer, and I'm from Iwachain. And I have some experiences on using Tendermint like Cosmos SDK and Tendermint Core using Go language. And I am studying Rust language, so I can write smart contracts on Rust and read the code in mid-level. And I want to ask to develop parachains to get commercial level. What should I concentrate on more study? Because there are some gaps between language tutorials and real code. So can you give me some tips?
Yes, for sure. I think so. The best person, like, you know, to reach out to is like giving a talk like next week. So Sacha is from like Parity. So they sort of like keep track of, or, you know, maintain the Substrate docs, the Substrate tutorials, everything that you see. So Sacha would be like the best person to give you pointers, but know that we are like trying to put out some educational resources out there. So there's a massively open course that is planned. So that's going to give you introduction to Rust and Substrate. But yeah, so these are like long-term plans. Like by the end of the year, we want to give out these courses. But more immediately, I would ask you to reach out to like Sacha next week.
Thank you. And your t-shirt color is Polkadot color.
Yeah, Polkadot t-shirt, actually.
Oh, it's very cute.
Yeah.
Can I have one more question? Like, so I think there is a limitation for the parachain slot, right?
Yeah. So the number is 100. Like I mentioned, it's like an arbitrary number. We don't know the exact number yet.
Oh, so it can be more larger in the future, right?
Yes. So there are different optimizations we have to do. And the way we know that it works is actually seeing it work in the real world. So it's like with simulations and everything, you can only do this much. So we want to have, so Kusama is mainly for that. So if you look at the auction schedule on Kusama, we're like, you know, every week we're trying to add like a new parachain to the, you know, relay chain. So we want to see like where the breaking point is, like when we keep like adding new parachains, where exactly does the network like feel the stress, and seeing like the reason why, you know, the network is feeling stress, improving on that, optimizing it further, and you know, add more chains. So the only way to do that is having these parachains on. Like, you know, we don't know what kind of problems they might bring, you know, with them. So it's all like a real world experiment that we're doing on Kusama. So with theoretical like benchmarking and you know, experiments that we did, we felt about 100 parachains is when the network will start feeling the effect, mainly because of the networking issue, because the validators, you know, so we want to ensure that at least 5 validators are working on a parachain, right? So with 100, we have about like 500 validators, or even more, like 1,000 validators. So each validator has to gossip at the, you know, the blocks or transactions across each other. So the networking effect, the voting that goes, like grandpa involves like some voting, like, you know, there has to be some consensus, you know, mechanism between the nodes, right? So we feel like about 100 is where we'll hit like some bottleneck. But again, like you have to understand that 100 parachains means each parachain can host, think of like a Ethereum, like how many applications is it hosting? So 100 Ethereums kind of thing is like scaling like even more, right? So this is just like, how would I put it? It's improve as you go kind of optimization that we're looking at. So right now there are complaints about like Substrate parachain block times. So block time is like about 12 seconds, whereas the relay chain is like 6 seconds, and only like limited transactions can go on a parachain. So there are optimizations there as well. Core developers on Parity from Parity are working on asynchronous backing. So asynchronous backing is when there need not be any active channel where collator submits a block to the validator. Instead, the collator can send it and keep doing their work. So that's going to improve like the parachain user experience as well. So yeah, a lot of things, but the architecture is there, and it's delivering the security, shared security and interoperability, and you'll see more and more of these improvements and optimizations on the network.
Okay, like one more last question. Maybe others want to have question themselves. So there is Kusama network on Polkadot, maybe, right? And
no,
Kusama
is a separate network.
It is separate, like, right. I'm just curious that if you guys think Kusama as a testnet or like subnet or just the other alternative network. It was kind of curious.
So Kusama is a canary network. So we have test networks, like we have plenty of test networks. So we have Rococo. Someone asked about like why Rococo's state needs to be like reset. Why can't you do on-chain upgrade to it?
Yeah.
So I have an answer for that. But yeah, so Rococo is a parachain testnet. We have Westend, which is like a Polkadot testnet. So you as a developer, you won't build your applications on Kusama right away. So you'll start with one of these like testnets. So the testnet tokens are free. So you have a faucet. So you can download that and then start like working on your like parachain project. So Kusama is a canary network. So canary network, that name itself comes from like a canary bird. Like people before like mining, they used to take like a bird to the mine or the cave, which is like underground, and make sure like the bird is healthy. So if the bird is not healthy, so they're going to take precautions or they're going to abandon that plan altogether. So you have Kusama Canary network, where it's like a fully functional economical like chain with economic value. So Kusama token has like an economic value, right? So you, even though your logic is bug free, like everything is being executed as expected, is this core logic, will people take advantage of it? Can people extract value out of like the core logic? How do you test that? You have to test it in like real world blockchain with like real users, right? So no matter how many simulations you do, you can't identify that kind of behavior unless you're running it in like real world testnet. So it's somewhere in between testnet and production. So it's like this intermediate chain where all the advanced features are tested and innovated. There's a rapid innovation there. So the stake is lower than Polkadot. So if you fail in Kusama, it's better for you, because if you fail on Polkadot, then you have significantly a lot of things at stake there.
Okay, thanks.
Can I just ask you some questions? Mm-hmm. Hi, I'm Myung-Ha Cho, and I'm a junior front developer, and I'm from Scripto. And I'm the one who asked about the Rococo testnet. Mm-hmm. And why don't you just make another testnet?
Oh, that is exactly what they do. So, so if you think of like a test net, it's not actually a physical network, right? So you spin up a bunch of nodes, you know, on different servers, and then those nodes sort of talk to each other. They build like a blockchain, and that's how like the blockchain network sort of lives. So Rococo is mainly for like the cross-chain communication, like XCM, and all the new features are tested there. Sometimes like the network state itself gets corrupt, like the blockchain state itself is corrupted because the code was buggy or something went really wrong. So the state transition wouldn't make sense when you have like a corrupt like blockchain state. So people tend to like simply like reset the whole network, start with the Genesis, you know, thing, and then start like testing like cross-chain communication. Whereas West End is like another blockchain you know, test network. It's never reset. It's almost like Kusama and Polkadot. It keeps like adding like blocks on top of each other. The state getting corrupted on this, the probability is very, very low, because you know the underlying you know, block consensus and blocks being added, the transactions, everything follow like tried and tested code. So nothing of that sort happens there. So Rococo you know, sometimes has this like state corruption problems. What they do is, because all you're trying to check is like cross-chain communication, it doesn't matter like what the testnet state is actually. So if you think about it, so yeah, so that's why they tend to like reset it often.
Thank you. And basically, the Polkadot network just validates Parachain's blocks and transfer messages between them, right? Are there another fundamental concepts only in Polkadot?
So right now, the parachains, when they're communicating with each other, so they talk through the relay chain, which is like Polkadot. But in its full like glory, like with XCM v3 and like XCMP upgrades, so the parachains can actually talk to each other without like going to the relay chain. So by establishing certain kind of standards. So there's one more thing called a spree. I'm just going to put it in the chat. So spree is like this standard library of code that every parachain or you know, project is going to agree on. Like, you know, people, so it's like an open code. Everybody knows what that code does, and sort of agrees on that, and then talks to each other trustlessly with like spree modules. So this XCM, and the reason like XCM sort of like supersedes bridges is that when you create a bridge, so you have like, let's say Bitcoin, you have like Ethereum, you have a bridge which is maintained by certain validators, right? So if you corrupt those validators, you could actually do real damage to people on one side or the other. So in Polkadot, like the interoperability, it's not taken care by these bridges with like limited set of validators who can be corrupted. It's part of the design where you have, you know, all the validators on Polkadot participating in like, you know, letting chains talk to each other. So in a way, like the network's stake is protecting everybody. So it's not like, you know, to corrupt the validators to do some damage to the parachains. So you need to actually like get a significant stake on the entire Polkadot like network to be able to do that. But again, like forkless upgrades, like I already mentioned, it's unique to like Polkadot ecosystem. Substrate kind of framework. So you can argue that Cosmos has like an SDK as well. Someone already like was developing on Cosmos SDK. So it comes with like Tendermint, like consensus engine. But again, like you don't have the option to you know, diverge from that, right? So Tendermint is like a provable finality. So it comes with theoretically, you know, itself, like the chain can stall if there is no consensus. The network sort of stalls, and you can't add like new blocks on top of it. Whereas Polkadot has, you know, So grandpa based consensus, which is like a hybrid. It's a hybrid between, so it keeps the network alive, you know, so blocks can keep getting added, so they get finalized with certain lag or whatever. But overall, if you see, every single chain in the ecosystem focuses on one or two aspects, whereas Polkadot is sort of, you know, focusing on a spectrum and trying to create a resilient like blockchain ecosystem that is sort of future proof.
I got it. Thank you. And lastly, the DOT tokens usage is currently only for governance.
Staking, governance, crowd loans. You know, if you have to do something on chain, like setting an identity, creating like proxies. So anything to do with like Polkadot network, you would need like DOT tokens. But mainly the use cases are staking, crowd loans, and governance.
Okay, thank you.
Okay, Radha, I can see you are a little bit thirsty, right? So yeah,
part of the job, so
yeah, our lecture is taking like 2 hours.
Mm-hmm.
Let's have one last question from this, and we can wrap up this class. Any more questions?
Yeah, so I would say like check out the Substrate Stack Exchange. So I've been learning a lot from that as well. I'm gonna drop that link to you. So there are over 700 questions on it, and almost like everything that you asked me today, like, you know, one way or the other, you would find similar questions there. So you as developers, I think you can use that as your primary source of information, because you can directly interact with the developers who are actually developing Substrate. So that one, and then let me give you the tutorial link as well for you to be familiar with what was that, Frame. So that's going to help you, you know. Right, so get that, and yeah, these two links. So just keep track of of the discussions on Substrate Stack Exchange. Take a look at this Frame palette creation tutorial. They should like put you in a good shape in general. And for the next session, you'll have like much more idea of the capabilities of Substrate.
Okay, thank you. Yeah, we definitely will go through this tutorial. Also, we will get all the questions and posting in the Stack Exchange to share with us.
Yeah, either that or give those questions to Sacha like one day earlier, so he can like prepare and then give you like a better answer.
So there's no other questions, and yeah, I think we can close the lecture today.
Sure. Yeah.
Thank you very much, Radha.
Thank you all for attending.